Hi, today I want to share a little achievement that makes me happy because for some times I set for myself this goal to publish an article on InfoQ, and I tried proposing some topics in the past, didn't work out. But now, as of yesterday, I got my first article published there. And this is about migration pipeline. So an approach to define migrations from legacy code to modern programming languages. This is a topic that I'm devoting a lot of attention to recently, and I'm going to present on this topic in Milan in a couple of weeks, and in late November I will be in Strasbourg at DevFest talking about this. And so, it's I am focusing on one topic and try to promote it instead of inventing a new topic for each presentation. So this is about reuse. Very proud of myself. Now, we can take a look at the article. And by the way, I was working on the demo for Milan, and it's very connected. But yeah, the article is a pipeline approach to language migration, and of course, you can take a look and read it. But right now, I would like just to share the key takeaways. And I find it interesting that in InfoQ they have this schema, so you always start the article with the key takeaways. So you know what you're getting if you put the effort in of reading the article. And yeah, the first point is that it is possible through automated code migration. Oh, let me get this out of the way if I can. No? Okay, apparently I'm not smart enough to change the position of this. Let's forget it. Okay, the first takeaway is that it's possible to create automated language migration that produce code that is maintainable and idiomatic. And this is for me a very important point, because I think that some of the approaches used to migrate code have produced code that sort of worked but was terrible to maintain. So you may have heard of the term Jobble to indicate COBOL code migrated to Java that smells like COBOL. It's syntactically speaking Java code, but it is written according to the mental paradigm of COBOL developers. And I think that if your migration approach is naive, there is a high probability to end up there. But I want to stress the fact that this is something you can escape if you use the right technique. So automated migration can produce code that is idiomatic. It's code that people can be reasonably happy to maintain. The second point is that a step-by-step pipeline approach permits to break what is a very complex problem into a series of much smaller problems, and it lets us inspect these intermediate steps. If you want, it's the contrary of what LLMs do. LLMs, like neural networks, like other systems, are black box. You throw some stuff into, you get some stuff out, you don't know why, and it's create a similar effect to the one you had with the cargo cult. If you don't know what it is, Google it. I think it's interesting example. So you have no control on what is happening. You just throw the inputs, hope for the best, and if you don't get what you wanted to, okay, maybe if you slightly change your prompt, who knows, maybe the LLM's gods will answer your prayers and give you a good answer, but in reality, you have zero control of what is happening. Pipelines are the contrary of that, because they're based on an algorithmic approach, and they permit you to inspect what is happening at each stage, so that if there is a problem, you can spot it, correct it, refine it, and continue. Another point is that, the third point out of 5, is that migration pipeline can and should be tailored for the specific needs. So the architecture is presented in this article, but is a flexible architecture by nature. There is a combination of stages that you can combine, rearrange, you can add some, you can remove some, you can customize one of the steps. So I want to stress the fact that there is flexibility and you can adapt to your specific needs. Another thing that I wanted to underline is that pipelines are similar in nature to compiler, in the sense that there is a sequence of steps, a clear systematic engineering approach. So it's not a black art, it's not art at all, it's just engineering, some discipline. So boring stuff, but stuff that works. And finally, I wanted to stress that in this approach, we use LionWeb to represent these intermediate states, and LionWeb is an open specification with implementation in multiple languages, Java, TypeScript, Python, C#, and more to come. And given we represent these intermediate stages using these open technologies, you can inspect, take a look, create tests that verify if the content of any stage respects certain guidelines or certain rules that you decided. And also, by the way, it also means that you can implement different stages with any of the languages that are supporting LionWeb. So given that basically every stage read a starting state in LionWeb, does something and produce a final stage in LionWeb, and given that any LionWeb stage can be implemented using, at this time, Java, C#, Kotlin, Python, TypeScript, and others to come, it means that you can have a pipeline composed by different elements written in different languages, and I think this is an advantage. And yeah, so these are the key takeaways. Hope they make sense. And if you have questions, if you're curious, very happy to talk about this subject. So just let me know your opinion. Thank you and have a great day. Bye.